Do you see that? Now certainly this is a little bit more energy. I mean, I'm with you. But it's not dramatically more energy. All right, we got one more step, right? What have we got to do now? Well, we're at 100 degrees. And the stoves are popping, and the things is about to start to boil. And do what? Release steam. That's called vapor, right? So we need the heat of vaporization now on step 4. So what is the heat of vaporization? 50 what? 2259 times the mass, which is 13. So 2259 29,367 joules. That's huge. And what have we done? We've just went there. We've stayed at the same temperature. Let me write that down. We have went from water at 100 degrees centigrade to what? Steam, which is a gas, at 100 degrees centigrade. Have we changed the temperature? But how much energy has that taken? A huge, huge amount of energy to go from here to here along this isotherm. We're not at 103, yeah? What at 103? Oh yeah, one more step. We're about there. All right, now we had the specific heat of ice. Now I need to look up the specific heat of steam. All of these, by the way, would be given on the test. They would have to be naturally. 0.48. So it's about the same thing as this. Okay, the magic number is 2.008 joules per gram degree centigrade. Okay, last step here. This is step 5. We're going to go from steam at 100 degrees centigrade up to a steam at 103 degrees centigrade. So that's going to be a mass, which is 13, times the specific heat of steam, which is 2.008, times the final temperature, 103, minus the initial at 100. Okay, so it's going to be 13 times 2.008 times 103 minus 100. So we're getting 78 joules. And 78 joules would be the amount it would take to go from here to here. So that is step 5. So now, to answer the question, how much total energy then is going to be required to heat all this up? Well, 135.98 plus 43.55 plus 29.67, 367 plus 54.39 plus 78. 35,063 joules. Now, what is the step with the most amount of energy? Is this right here? Changing something from a liquid to a gas. Why is this the most amount of energy? Hydrogen bonds. What'd you say now? Breaking bonds. Hydrogen bonds. All right, breaking the hydrogen bonds. Have I got something added up wrong?
I got 39,000.
Instead of 35,000, you get 39,063?
39,645.
On his 43. Yep. I did put 0.5. So you're getting 39,374? All right. That's going to be 39,374 joules. So have you ever noticed that? Like, you got water on the stove. Of course, naturally, a normal human being wouldn't put their hand in the water on the stove. But it's hot long before it officially comes to a rolling boil, right? I mean, are you with me on that? I mean, do you think that I could have some water here and boil it? But it's not boiling yet. It's just been sitting there quite a while. It's not boiling. And I just throw that on John. I mean, is there a possibility he's going to be hurt? Yeah. I mean, even if it's not boiling, right? Why? Because, okay, we can melt the ice and we can do this and then we can get here. It ain't going to boil. It's going to just sit there. You just have to cook on it and cook on it and cook on it and cook on it, and then it's going to start to boil. Well, let me tell you something. Right here is hot. What's the temperature? 100 degrees. So you throw that on his face even though you ain't officially boiling, I mean, you still got trouble, right? All right. We ready to go home? Let's go home. This marker's about dry.